Every year 8.6 million cubic meters of water flow through the mountain range of Nepal. This huge hydrologic network consists of over 6,000 rivers, making up 2.7% of Earth's fresh water. It supplies over 1 billion people downstream in India and Pakistan. Besides being vital to human and non-human existence, water is the determining force of morphologic processes. Landslides, floods, water-related diseases, as well as soil degradation caused by erosion lead to huge damage to the economy and to human life. With a constantly growing population, especially in cities, the human impact on the water quality became increasingly significant. In order to rethink the strategies of how urban sprawl should take place, we have to analyze the topography from different perspectives and understand opportunities as well as risks of hydromorphologic processes. Just like this water plant, an urban network has to adapt to a variety of external parameters, especially the hydrology. A new planning workflow is needed that incorporates the knowledge about the environment in order to generate a new urban network that combines both human and non-human interests. Particles, which represent human and non-human agents, are influenced by different forces and reorganized to optimize distribution. By overlapping both networks, dense spots become visible. These are the areas with high surface water deposit. To loosen these tensions, water has to be redistributed in a more efficient way. For this to work, I use water elevating towers, a low-tech approach that has been used in the late 19th century. It uses hydrostatic pressure to transport water from one side of a valley to another. I adapted this linear approach of transporting water to apply to the 3D topography of Kathmandu. A flowline analysis calculates the local high and low points, defining the points where water is distributed from and where the water will be absorbed. Together they form an interconnecting network that allows water to be freely distributed around the entire topography of the Kathmandu Valley. Machine learning is further used to translate data, for example from erosion drawings, into a satellite image. This allows me to create output images that correspond to the calculated geomorphology of the landscape. Additionally, the flow behavior of the water can be overlapped as an extra layer of information, transforming the landscape. A new distributed urban environment is generated, which entirely adapts to the hydrology of the landscape, allowing water to be freely distributed to any desired location of the landscape. This landscape considers the characteristics of the topography and distributes human as well as non-human networks accordingly.